Okay, ladies and gentlemen, if you have not watched the first video of the Cessna 172 airplane familiarization, I encourage that you go back and take a look at it. But at this point, we have gone through the engine start process of the Cessna 172, and you're actually looking at the actual panel, the actual switches that you would see in a Cessna 172 are here in the simulation. That's why I think the system is so great. But at this point, we've already done our engine start checklist, and we are going to pretend. We're not going to pretend. We're going to do a takeoff simulation, and so we're going to go through a before takeoff, and we're going to execute a normal takeoff. All right, so. Let's see here. To me, this is a more functional, depending on what you're doing, it's a more functional. We didn't want to go there. I didn't want to hit that button. Okay. What we have here is a communications assistant box here, and we can tune in to Trenton ATIS. The ATIS is the Automatic Terminal Information Service. Every airport does not have an ATIS. You have two types of airports. They're tower controlled airfields, and then you have uncontrolled fields with no towers. If you're from the Jersey area, Trenton Mercer Airport has a control tower. It is a controlled field. At night, I believe after 10 o'clock or so, the tower is closed, and then you would use uncontrolled field procedures. But the automatic terminal information services on 133.7, it's very similar to tuning your radio. 133.7. Now you have it's a dual knob. There's an inner knob and an outer knob. The outer knob, when you rotate that, it turns the digits to the left of the decimal. When you turn the inner knob, it moves the digits behind the decimal to the right of the decimal. So again, here, COM 133.7 is on standby, and we will go ahead and listen to the automatic terminals information service that tells us what's going on at the airport.
Airport information, Victor 17070, with visibility greater than 20 miles, sky conditions clear, temperature 152.5, altimeter 2992, ILS, runway 6 in use, landing and departing, runway 6, VFR aircraft, state direction of flight, all aircraft feedback hold short instructions, advise controller on initial contact, you have Victor, airport information, Whiskey 1.
Okay, alright.
152.5, altimeter 2992, ILS, runway 6 in use, landing and departing, runway 6, VFR aircraft, state direction of flight, all aircraft feedback hold short instructions, advise controller on initial contact, you have Whiskey. Airport information, Whiskey 17.
Okay, now we're in the ground control frequency. Now, basically it's a clear day. Visibility is greater than 20 miles. Sky conditions are clear. Very few or no clouds in the sky. Temperature is 15. And that is not, well, just for simulation purposes, temperature is 15. We'll just leave that right there. 59 degrees Fahrenheit. That is our outside air temperature. And 1309, which is 109, is the current time. They gave us time in Zulu time, and we'll talk about that at another time. But Zulu time is the pilot time. The pilot times. No matter where you are and what time zone, we use Zulu time because it doesn't matter where you are. If you're using Zulu time, you're aligned with a certain time. So runway 6 is in use. So what we could do is go to our outside view, top down, and this is where we are. Alright. Ronson Aviation is there. Frontier Airlines is over here. This airplane or this airport is located in Ewing Township. Major highway 295 is running around here. 30, is that 31 or 29? It's 29. 29. Here's the Delaware River. Alright, 295 comes in. Actually, this is still 95 at this point, I believe, and then it turns into 295. And then you float around the airport, and it goes through Ewing Township, Lawrenceville Township, into Hamilton Township. This is Route 1 right here. Alright, so, but we are going to runway 6, which is down here. This is runway. This is actually 2 runways. This is runway 6 down here. This is runway 2 over here. The runway you're using depends on the magnetic direction that you want to take off. And again, we'll talk about that in another video, but for our purposes right now, we are here. Okay, so at this point, what we do, this is the parking brake. We pull it back and then we rotate it to the left to release it. Alright, and around first before we do any type of movement, and then what we're going to do is we are going to talk to ground control so we can get clearance. This is a control field. We have information Victor, so basically what I would say is, and this is the tail number, Golf Bravo Alpha Mike, Alpha Foxtrot Mike, sorry about that, Golf Bravo Alpha Foxtrot Mike is ready to taxi with information Victor. And I would say Trenton ground. Okay. And we're going to depart to the east over like Bridge Mall. So we're going to request taxi, and it's going to show you specifically what the pilot would say and what the ground controllers would say.
Trenton ground, Cessna Golf Bravo Alpha Foxtrot Mike with Whiskey, request taxi for takeoff, departure to the east. Cessna Golf Bravo Alpha Foxtrot Mike, taxi to and hold short of runway 6 in taxiway Hotel Alpha Juliet. Contact tower on block 2 0.7 when ready. Taxi to and hold short runway 6 in taxiway Hotel Alpha Juliet. Cessna Alpha Foxtrot Mike.
Now, just to give you an idea, basically with the radio phraseology, we say who we're talking to, we identify who we're talking to, who we are, and what we want, basically. So who are we talking to? Trenton ground. Who are we? Cessna Golf Bravo Alpha Foxtrot Mike. I know that's a lot. With information whiskey, it changed to information whiskey, which was the ATIS information. So what you're telling the ground controllers is like, hey, we know the current airport positions because we have information whiskey. What do we want? We're ready for taxi, for takeoff, departure to the east. The ground controller responds the same way. Who's he talking to? Us, Cessna Golf Bravo Alpha Foxtrot Mike. Taxi to and hold short of runway 6 by way of taxiways Hotel Alpha and Juliet, and then contact tower 120.7 when ready. Okay, so we have that information, and what we do is we look around first. We just don't go moving airplanes, and we advance the throttle a little bit, brake test. You can see that the aircraft is rolling, and then we tap the brakes, and the aircraft stops. Okay, that confirms to me that the braking system is functioning properly. And what I've done is I've instituted a little taxi. This is representative of a controller basically watching you. Alright, and what we would do is we would go to one hotel, not one hotel, we go to a taxiway hotel, which we're on. If we look at the sign there, let's see, let's let her go forward a little bit. You're going to see a sign. The black sign says, this is the taxiway that you're on, or this is the street you're on. Alright, so the ground controller would be watching you from the tower, and you say, make your next left on the Alpha. You see hotel, we see a left turn to Alpha. Okay, so hotels where H or hotels where we're on, and then A is Alpha. We say things phonetically so they can't be misconstrued. Over the radio, A could sound like J, but we distinguish by saying Alpha and Juliet. B, D, C, E could be misconstrued if there's radio static. So we would say Bravo, Charlie, Delta, E, Echo. Alright, so there is a phonetic alphabet that we use that was instituted by the International Civil Aviation Organization, so that every pilot in the world, no matter where he or she flies, can use a common phraseology no matter where you were. If you were in South America. And another thing is, everybody must learn English. Everybody has to learn English. It was almost, you had all the countries get together and say, hey, okay, what language are we going to use? What's going to be the official pilot language? The official pilot language is actually English. And it was almost outvoted by French. So, us being Americans and wanting to be pilots, we would have to learn French language if we wanted to pursue pilot's license, be it private or professionally. Okay, so we're currently on taxiway Alpha, and we're gonna think of taxiways as streets. Basically, hey, make a right turn here, make a left turn there, but basically all we're doing is getting ourselves to the runway. I don't have rudder pedals at this time, so the steering is a little squirrely, but we're getting the job done with the key presses. Here's our right turn on the Juliet, and I think you saw that AJ and the arrow there. If you didn't, you can pause and go back. Another thing is, your taxi really should never ever be any faster than a brisk walk. Especially, when you start training, you want to take it nice and easy. Another thing, you don't want to ride the brakes. You should never ever be moving at a speed where you have to ride the brakes. It's synonymous with applying your gas pedal in your car and stepping on the brakes at the same time. Not wise. You wear the brakes out. And we typically ride with our nose wheel on the solid yellow line. That is runway 624 out there. It's either 6 or 24 depending on the magnetic direction that you're pointed in, but we are going to be pointed in a magnetic direction of 60 degrees when we depart runway 6 at Trenton Mercer Airport. Now, since we're using 6, that means that the winds are coming from a direction of 060 degrees. So we're going to do something called a engine run-up or pre-takeoff check. Where we would point ourselves, get off to one side of this taxiway, not running into the grass, but just off to the side just in case other aircraft are ready to take off and they need to get around us. We're not inhibiting movement, so an aircraft could taxi right by us and we're not blocking them. Okay, so now we do a before takeoff check. The parking brake is set. I'll just reset it just so you can see it. Okay, the parking brake is set there. Our cabin doors and windows is locked. They're closed and locked. This lever is rotated all the way forward, indicating that it's locked. This is rotated all the way forward, indicating that it's locked. So cabin doors and windows are closed and locked. Flight controls free and correct. When flight controls are free and correct, what that means is we take our controls and we move them to their full range of motion to make sure that our legs, nothing is blocking. In addition to that, we kick our rudder pedals. I'm trying to see here. In addition to that, we kick our rudder pedals around. We can see our foot pedals, our rudder pedals are moving. So what exactly is this doing? This is actually, as we make those little movements, I'm trying to get a better view here. So as we do that, what we're doing is we are kicking the rudder pedals around. You can see the vertical stabilizer moving the rudder, or the rudder moving about the vertical stabilizer. We're moving the elevator now, and now we're moving the ailerons. Alright. Another thing we could also do is we could extend our flaps. Okay. And we use flaps for short field takeoffs and landings. This will be a normal takeoff, so we don't need flaps. We got like 6,000 foot of runway to operate with. Alright, so now what we want to do, check our flight instruments. I'll go to our instrument window and let's see. Our flight instruments, airspeed indicator 0. Attitude indicator is erect and stable. Now, it was all disheveled earlier, but now it's erect and stable. This orange represents the miniature airplane. The background represents the sky and the ground. Okay, so we're level, we're on the ground and level, so obviously the wings are level. If the dot moves upward, that means that we're climbing. If it goes downward, that means we're descending. Okay, so that's our attitude indicator. It is what we would call erect and stable. Our altimeter is set for 213 feet. Our vertical speed indicator is indicating 0, which means we are not climbing or descending. And then we cross-check our directional gyro with our magnetic compass. And since this is not a slave gyro, which means it's not slaved to magnetic north, every 15 minutes or so we need to readjust this using this button. We need to adjust this with the magnetic compass, because this is a continuous north. It continuously seeks North Pole. There's little magnets in here. And our turn coordinator. Alright. Before, when the aircraft was off, it was saying, hey, we're off. Now it's out, so we are on. Let's see, our oil pressure, our oil temperatures come up a little bit higher. And go ahead, we'll set that off. We'll turn it back on for takeoff. Okay, flight instruments are checked and set. And typically, it doesn't take this long to do this, but I have to explain things. Our fuel selector valve is in the both position. Remember, it could be on the right, it could be drawing fuel from the left, but in the center, it's in the both position. Fuel selector valve is both. Our mixture is not lean, it's rich, it's all the way in. Our elevator or rudder trim, we set that for takeoff already. Remember, I made the little joke about TO. Alright, our elevator trim is set for takeoff. There's a little arrow, and we want it lined up with TO, so the trim is set for takeoff. Where you would see that in real life is here. Alright, and we would roll this wheel. We can roll this wheel down, or we can roll it up. Alright, but we roll it down, but we want it lined up with the line, so we would roll this up until the line is perfectly lined up. So the elevator trim is set for takeoff at this point. We'll talk about trim tabs later. I'm going to go to our little instrument screen here, and we're going to slowly advance the throttle by pushing this in until we get to 1700. Now, the simulator is going to let the plane roll a little forward. If the parking brake was on, we could go to 1700 without any issues. So we'll go ahead and advance the throttle to 1700 RPMs. We're at 1000. We're going to move 2 clicks above. We're going to push in the throttle till we're 2 clicks above 15, meaning that is 1700 feet. 1700 RPMs, I'm sorry. Advance the throttle. And I'm doing it slow. And you can watch the throttle being pushed in. You could hear the engine revving. Now, at this point, what we want to do is we want to check the spark plugs, or what we would call magnetos. Unlike your car, I don't know, some cars may have 2 sets of spark plugs, but our engine cylinders have 2 sets of spark plugs, and we do this for better engine performance. What we would do is we would just basically go to the left set of spark plugs. We would get a drop in RPM. Then we go back to both, and it'll go back up to 17. We check the left, get a drop, go back to both, it goes up. We'll turn the key into the right magneto position, we'll drop again, and then go back to both. Alright, now, when we go to each key position, being left, right, okay, when we go left to right, this needle should not drop more than 1 1/4 of a click mark. Alright, 1 1/4, that represents 125 RPMs. And then we have to note the difference between what the settings were, because whatever the drop was should not be more than a half a click between left and right magneto indications. I will go in depth with that in another video, don't lose your mind over that. We check our engine instruments and we make sure that they're in the green. Alright, fuel flow's green, oil pressure's green, engine temperature's green. So our engine instruments are green, and our ammeter is giving us the standard indication. It's not overcharging and it's not discharging. See the plus and the minus there? It's right in the middle. So that's where our electrical system should be. In addition to that, suction gauge check. Our vacuum instruments are in the green. This is the suction gauge, and it's in the green. Alright, now the vacuum is going to drop. Oil pressure is going to drop when we go back down to 1000. Alright. So at this point, we're going to go back to 1000 RPMs, and those engine instruments are going to give us the indication. We'll get to drop in vacuum as we pull the throttle out or release our foot off the gas pedal. A little too much. Don't want to be there. And if it's like around 1000, it's okay. We're just idling. It's not a big deal. Okay, so let's get the right view here. There we go. So we're going to go ahead, we're going to release our parking brake. And the tower frequency was 120.7. Now I can even go here and just go to the specific radio. Ground control is 121.9. Tower control is 120.7. I'll set that up in the standby. I'll hit the swap button, or switch, bang, and now we're on 121.7. Alright, at this point what we will do is we will get ourselves ready. Now I have a memory aid called lights, icing, flaps, transponder, which means lights. We would turn our landing light on. Fuel pump comes on. The strobes will come on. Flaps we would set to 0 for short field. Transponder goes from standby to the altitude encoding position. And 1200 is a common transponder code to let radar guys know that, hey, this is a visual flight rules airplane, meaning that we're flying by reference, visual reference, as opposed to IFR, which is instrument flight rules, and we would have a whole nother transponder code set up. This is going to be the normal takeoff. So we would just kind of stop right here. Just want to get a little bit closer because there's some hold short lines that we need to be familiar with when we operate at controlled airfields. Because we were cleared to taxi 2 and hold short of runway 6. Let's get outside view. There we go. There's our aircraft. These are the whole short lines. Alright. Anytime we see a solid line, just like when we're driving, you're really not supposed to cross it. If the lines are broken, you can cross it. Alright. So let's say if we were exiting the taxiway, we don't need permission. If we landed on 24 and we're taxiing off here, we don't need permission because the lines are broken to taxi on to the taxiway. But before we get on to runway 6, we need permission, and that's where the air traffic controller comes in. Alright.
Tower, Cessna, Golf, Bravo, Alpha, Foxtrot, Mike, ready for departure to the east at runway 6. Cessna, Golf, Bravo, Alpha, Foxtrot, Mike, clear for takeoff, runway 6, east departure approved. Cleared for takeoff, runway 6. Cessna, Alpha, Foxtrot, Mike.
Okay, now I'm going to go to radio phraseology really quick. We called the tower, we said Trenton Tower, Cessna Golf, Bravo, Alpha Foxtrot Mike's ready for departure to the east at runway 6. We're saying, hey, who we're talking to, Trenton Tower, who are we? Golf, Bravo, Alpha Mike. What do we want? We want to let them know we're ready to go. Departure to the east at runway 6. And then the tower, he says, who he's talking to, hey you, you're clear for takeoff, runway 6, east departure approved. So we're cleared to depart. I'm just going to set this up here. 25 feet is good. Let's set up a heading indicator. Runway 6 is our runway heading. And this is just some general housekeeping, I call it, just to let us know. It's just giving us a general idea of what we're going to be doing, or a reminder. Not that we would forget, but it's just some things that are just a little helpful. But just reminding us what runway and what altitude. So we basically have a plan, we're just not boom. Okay, so our normal takeoff is wing flaps up, there's no carburetor heat, we have our fuel pumps on. We're going to open the throttle, we're going to raise the nose wheel at 55 knots. Okay, we'll line up with runway center line, I'm sorry. So we line up with the runway center line. Right. And so for our takeoff briefing, we're going to just slightly raise the nose wheel right before we get to 60, that's 55 knots. And then we're going to let the wings aerodynamically take the load off of the landing gear, and the lift starts being generated and we start climbing. And we want to climb at a speed of 70 to 80 knots, so that is the normal takeoff. A couple other things, when we take off, we don't look right here, we look down the runway. The extended center line of the runway is where we want to be as we accelerate. We don't want to be looking here chasing this line. We want to be looking down. We'll rotate, the nose will come up, we won't see the runway anymore, but we will have our side reference views to let us know how far we are from the edges. And then after that we take off and we maintain a heading of 060, and we're going to take that all the way up to 25. Now we're going to take the 1200 and we're going to execute a right turn. Okay, so full power, raise the nose at 55, climb out at 70. Real simple. Here we go. Full power. Looking at the airspeed indicator, airspeed is alive. .55 knots, gently rotating, gently raising the nose wheel. Okay, and we're up. We want to climb out at 70 to 80 knots, so we're going to trim for that. 70 to 80 knots, we're a little slightly above 70, that is good airspeed. Our heading is slightly off to the right there, and we're correcting. Looking good. And I just wanted to look at something here. Spot. And what we want to do, the objective is to be on the, and we're slightly off, but the objective is to be on the extended runway center line. But we got blown off a little bit. No worries, we're correcting. Alright, we're at 1,300. And we're going to execute a right turn to east. And we'll roll out on the easterly heading, and we still have our climb out at 70 to 80 knots. We're going to keep our climb coming, and then we're going to come out of that speed range of 70 to 80 knots. We're going to start building our speed up. Power set. Engine instruments are still in the green. Our oil temperature and our pressure is good. Vacuum pressure is good. Ammeter's playing. We got our fuel flow. Fuel is good. This is Twin Pines Airport. It is a grass strip. It's a real airport. Let's see here. That's Ewing Township. And okay, so the tower says Cessna Alpha Foxtrot Mike, you're leaving my airspace, frequency change approved. So at this point, we don't need to talk to Trenton Tower anymore. I'm just going to go to this is a general frequency, clear that window, and we'll continue our climb. We're almost at 2,500 feet, and what we're going to do is we're going to level out. So the vertical speed indicator is going to go to 0, and the altimeter is going to stop its climb. And we're on a heading of east, and we're currently passing through 100 knots of airspeed, 115 miles per hour. And this is 295, probably. I'm trying to think what major road curves like that. We're in a heading of east. No big deal right now at this point. It's really bad. 115 knots, roughly. And we're just going to gently pull the throttle back a little bit as noted by our RPM indicator. And I'm just going to go to the instrument panel. So we're going to gently just pull the throttle back a little bit and get a nice cruise. So we're about 110 knots, 2,500 feet. I have the autopilot set at this point, so the autopilot is just going to make adjustments to maintain 2,500 feet. Okay, so that is the normal takeoff in the Cessna 172. So that's basically it. Any comments, questions, concerns? If you guys are doing any work in Cessna 172s and you'd like me to do a demonstration video on how you may need to navigate, plan, or anything of that nature, just let me know. Thank you for watching the video. This is Keno Thomas with Keno Trading Systems. Have a great day, and thanks for watching. Please like, share, and subscribe. Thanks.